And now I want to show you an alternative method, which is to make use of geometry to solve for the complex number that satisfy both this equation and this equation. And to do that, what I've done is I've already sketched the locus of this equation, which is the perpendicular bisector, on the same Argand diagram that is from the previous part of the question. This is that perpendicular bisector, and the intersection is this point and this point. I named them as P and Q. And you will also realize that this perpendicular bisector is going to cut the same, it's going to pass through the center of the circle with minus 5, 1 that we have sketched from the first part of the question. And now what do you make use of the geometrical property that I can find for this Argand diagram from the loci that I have seen here in order for me to find this point and this point. And to do that, first of all, if you were to look at this big triangle over here, for this big triangle, the distance from here all the way to here is from 6 all the way until minus 4, the distance is 10. And from here all the way until here, the distance is also 10. 10 and 10, this tells me that this angle over here, this angle got to be equal to pi over 4, 45 degree. And I'm going to make use of two right-angled triangles. One is here. If I were to connect this center to this point Q, first is this right-angled triangle, then it is this right-angled triangle, which is also going to be reference to the center of the circle, this right-angled triangle. For these two right-angled triangle, one more thing that I want you to be able to notice is that this angle here is also pi over 4. Why is it pi over 4? Because this is pi over 4. So since this line and this line, they are parallel, so by corresponding angle, this angle here will also be pi over 4. And since this angle is 90 degree, pi over 2, so this angle here got to be equal to pi over 4. And by making use of vertically opposite angle, since this is pi over 4, that means this over here will also be pi over 4. And now we are going to make use of some observation. Okay, if I were to focus on just this triangle first, for this triangle, like what we have just discussed, this is a right-angled triangle. This angle here is pi over 4. The hypotenuse of this triangle is the radius of the circle, so the hypotenuse is 4, which means that this side over here, is going to be equal to 4 cosine of pi over 4, which is equal to 4 multiplied by cosine of pi over 4 is square root of 2 over 2. So this is going to be equal to 2 square root of 2. The same for this. This is going to be 4 sine of pi over 4, which is going to be equal to 4 multiplied by square root of 2 over 2. This is going to be equal to 2 square root of 2. And the tip of this triangle here is point P. And the other tip that is here, it has a coordinate of minus 5 and 1, which means that at this point P, by making use of just observation, okay, I know the complex number z that is going to be at this point will have a real portion of the x coordinate, minus away 2 square root of 2, which means that the real portion of this is going to be minus 5, then going left by minus 2 square root of 2. This is going to be the real portion plus I of the imaginary portion. The imaginary portion is going to be the y coordinates of this point plus this length, which is 2 square root of 2. So it is 1 plus 2 square root of 2. And this is going to be the first complex number that is going to satisfy both this equation and this equation. Then at point Q, we can actually use the same observation, but now making use, similar observation, but now making use of this triangle. So if I were to make use of that other triangle, it is also going to be a right-angled triangle. And this angle here, like what we have discussed, is pi over 4. And this as the radius of the circle, so this length here is 4. Which means that this distance here is going to be 4 cosine theta. 4 cosine theta is 2 square root of 2. And this distance here is going to be 4 sine pi over 4. And 4 sine pi over 4 is also 2 square root of 2. And this point here has a coordinate of minus 5 and 1. and this is where Q resides. So at Q, the complex number that is going to represent this point is we'll have we have the x coordinate, which is the real portion of the complex number, as minus 5, then plus this distance, so minus 5 plus 2 square root of 2, where this is the real portion of the complex number, plus I of the y coordinate, then minus away this distance, so it is going to be 1 minus away 2 square root of 2.